Go ahead, John.
Hello, I'm John Grossman, a volunteer with the Forest History Association of Wisconsin, and I'm happy to welcome you to the first session of our September webinar series. This session titled Fire Weather, Fire Danger Conditions, which led to the historic Peshtigo wildfire of 1871. Our speaker tonight is Steve Marien, the Eastern Area Fire Weather Program Manager for the Eastern Area Coordination Center. For the last 20 years, Steve has filled this role by providing fire weather, fire potential guidance to the Eastern Area Interagency Wildland Fire Community. The Eastern Area is comprised of 20 states, making up approximately the northern quarter of the lower 48. Some people think of it as Minnesota to Missouri to Maryland to Maine. Steve combines weather forecasts and fuel condition data to produce overall fire potential, fire danger information. He works closely with the EACC intelligence officer who gathers current data on regional and national fire activity. Together, they provide critical response planning information for federal, state, and local government, as well as fire danger advice for broadcast by electronic media to the public. Tonight's webinar will begin the process of learning from events leading up to that fateful day 150 years ago, to try to understand how the actions of people, the state of the forest, and exceptional weather came together that fateful evening in 1871 to a tragic end. As I now hand off to our presenter, be aware of two issues for successful participation. First, note questions you have for the presenter and take time to pose them via the chat feature at the bottom of your screen. You will respond to them at the end of the session. Second, if new to Zoom and you have challenges navigating the system, pose those questions in the same chat screen and the facilitator will reach out to you personally during the session. Now, along with you, we look forward to this evening's presentation.
Okay. So as John said, my name is Steve Marien and I'm the Eastern Area Fire Weather Program Manager, and I'm happy to lead you through the drought and weather conditions leading up to the Peshtigo fire on October 8th of 1871. And like John said, I'll try to answer questions at the end of the presentation. So first off, just for clarification, the Peshtigo fire event, these are what occurred that day and the areas, that were burnt during the fire event. And just to note some things with the event, the numbers in red indicate the fatalities at each of these locations on this graphic. The blue are the directions of the surface winds, and we'll get into that more. And then also the location of, in this instance, a firestorm, which directly affected the Peshtigo fire, which received the greatest fatalities. And, we often see these firestorms occur, on more recent fire incidents. Like, you'll often hear of pyrocumulus or upward vertical motion occurring on fires, and that leads to exceptional fire behavior and fire growth. So I suspect that's what happened, or could have potentially happened near Peshtigo on that fateful day. So that's just to give you some perspective. I'm sure most of you know where the location was. This is I put this graphic together. Here's Peshtigo up here, north of Green Bay, Wisconsin. And then I'll be referring to, in the historical weather records, Sturgeon Bay across from Peshtigo, across Green Bay. This is where that is located. Then in Barris is 65 miles southwest of Peshtigo. So these two locations are a couple of the historical weather stations where weather records were kept way back then in the late 1800s. So that's, where those two stations are located. I just want to show you that geographically. So moving, like for instance, this is at Embarrass at that station southwest of Peshtigo. And these are the handwritten records, weather records, and also observations that this observer kept. I believe his name was J. Everett Breed. And he noted, just to point out, like, and Robert Zeal, who will be doing the next presentation, he'll get into this a little bit more, but this person noted very dense smoke all day on October 5th of 1871. And here's the temperatures per date, like at 2 p.m. Notice it was fairly cool on the 5th and the 6th. And then as we approach the date of the fire, it rose up into the 70s, like 70 on the 7th and 75 degrees at 2 p.m. on the 8th. So just something to note. And I found this very interesting that they could pull up. They found this handwritten weather record log, so to speak. So just to get into the weather setup for this fire event, this first graphic are the upper air, of 500 millibar, meteorologists call it, or the mid-level pressure anomalies. And it's approximately 15,000 feet above ground level. So just think of it that way. And if, where these are lines of constant pressure. So this would be where the jet stream is located. So you have cold air up north, and then high pressure, or ridge of high pressure, is what we call it, over the south central and southwestern US. So the jet stream's located up in Canada or along the border. So this is the mean height from July through September of 1871. So just the reanalysis of that. So they recreated through records, or tried to, of what the upper air weather pattern is. And so you had a ridge of high pressure off to the southwest of the Great Lakes region. And that was the dominant setup through the midsummer into the early fall of 1871. And I'll get into, this graphic shows under that ridge of high pressure, you have sinking air from aloft, and that air hits the ground and spreads out, kind of like if you had a fire hose and it's hitting the ground and spreading out because it has nowhere to go. So under high pressure, you have sinking air and divergence. And what does that mean as far as weather conditions? You've got clouds and precipitation are inhibited due to that sinking motion. Because you have less clouds, obviously you're going to have above normal or greater than normal sunshine with that high pressure around. And that also increases the drying of the fuels, which increases fire potential. And with that sinking air, you've got compression, and that leads to warming temperatures, or so above normal temperatures under that ridge of high pressure. So, with the northeastward extension of this ridge, and again, this is just the mean throughout this whole period. So that led to above normal temperatures, again, through that midsummer and early fall. And that's, so oftentimes when we start heating up here in the summer, this is it'll be extending more up into the Great Lakes, but this is a pretty typical pattern leading to the warmer than normal temperatures and drier than normal fuels due to greater amounts of solar radiation. So again, these are the mid-level height anomalies. So similar to the previous graphic, and this is July through September again of 1871. And you can see, we had low pressure off the mid-Atlantic coast, so cooler than normal conditions out here. And those greater than normal height anomalies were bullseyed right north of the Great Lakes up in southwestern Ontario. So all in here, that summer, just looking at this real analysis of the 500 millibar, that mid-level heights, that that created likely above normal temperatures, drying, and below normal precipitation. So that's the mid-level atmospheric setup. So what drought conditions led, theoretically, or, looking back in history, what were the potential drought conditions leading up to the Peshtigo fire? And I just threw this graphic in here. This is the current year, the leading up to all the fire activity we've seen over the northwestern Great Lakes this summer. So theoretically, this drought monitor, which has been done over the past few decades by all these agencies, if I had to project what this looked like in the early fall of 1871, I'm guessing that, they were in, at least severe to likely extreme drought in this whole area due to that above normal mid-level height anomalies and weather pattern. But I'll get into, and I do talk about the current conditions at the end of this just to do a comparison to what they may have saw back in 1871. So as far as the drought conditions, these are the recorded precipitation deficits leading up to the fire. Like here's the fire date is over in here. So, and this dashed line are the departure from normal. So as they went through from like mid-July all the way into, I would say, mid to late September, they were at a pretty strong precipitation deficit at this. This is Sturgeon Bay, so that weather station location across the bay from Peshtigo. So in Barris, this is the weather station southwest of Peshtigo, and the shaded areas are the precipitation deficits. So you're talking, this is the normal monthly leading in up to the fire date. So as they did start getting some rainfall late in October. Let's see if I can get this up there. But you can see leading up to the fire event, there's some pretty robust deficits at Embarrass, and then this is Sturgeon Bay. So you can see all the way from the summer into the fall, some pretty robust precipitation deficits leading up to the fire event. That's what the shaded area is. And these are from the historical records. Again, as far as departure from normal precipitation, this is the y-axis. So here's your departure from normals. Sturgeon Bay in 1871, and these are like other historical Great Lake fire years in the late 1880s into the early 1900s. So at 1871, they were almost, I would say, at a 7.5-inch departure from normal, leading up to the 1871 fire, the Peshtigo fire. And then at Embarrass, I would say like 6.25 departure from normal. So again, leading to, what we would assume some pretty significant, at least what we call flash drought conditions. And that kind of lines up with these graphics as well. So as far as the surface weather map goes, this is the surface weather map at 1 p.m. Central Standard Time on October 8th. So here it's a little hard to see. Here's Wisconsin here. So Peshtigo, here's Green Bay is located right where my cursor is. So you had low pressure centered over southwestern Minnesota with a warm front. In modern this would be painted, or in colorized graphics. This would be a red line here, and then a cool or a stationary front with the humps and the alternating blue and red draped back into the Central Plains. So in the Northern Hemisphere, around low pressure at the surface, the circulation is counterclockwise. So what was occurring, and these wind barbs are a little hard to see, but like this one in northwestern Iowa, you had very strong southwesterly flow pulling warm air out of the central plains and the mid-Mississippi Valley up into the central Great Lakes, south of the warm front and ahead of this cool front that's pushing into western Iowa. So right here at this station here, each one of these flags or barbs on the is 10 knots. So you had 40 knots or approximately 49-mile-per-hour sustained winds in northwestern Iowa. And it's a little hard, not quite as strong at this time over central Wisconsin, but you had very strong south to southwesterly flow up into the central Great Lakes. And that created, anytime you have southerly flow, you've got that warm air coming out of to our south over the central plains and mid-Mississippi Valley, pulling that warm air up into our region. So well above normal temperatures for early October. And I'll show you some of those temperatures here in a minute. Here's another iteration of that surface, and this is the evening of October 8th. So probably a little bit further after this graphic. So here's the low. This is, they just painted a broad surface low centered over the central plains back into the Rockies. And again, remember you have counterclockwise flow around a surface low. So this arrow designates all that southwesterly flow pulling the warm temperatures up into the Great Lakes and in the mid and upper Mississippi Valley. So these are the temperatures at these stations. And this is at 5:35 p.m. So a few hours later. But I mean, as you guys know, I mean, this isn't unheard of, obviously, in early October, but these are well above normal temperatures, 83 degrees, just south of Dubuque, St. Louis 80, Kansas City 85. And I believe it says the wind speed in green, but I think these numbers off to the right from historical records, these are the wind speeds. So you have 26 miles an hour, 22 miles an hour in Chicago, Milwaukee, I believe 32 miles an hour. So 83 degrees in Milwaukee, south of where the fire occurred. So well above normal temperatures. And these are the barometric pressure in inches. So as you go further into the low, obviously these numbers decrease. So and notice like in northern Utah, it's with that cold air being pulled down out of Canada, much cooler temperatures on the north and northwest side of the low. So warm air to the east of it, and then much 35 degrees in northern Utah. I think this is North Platte, Nebraska, 52 degrees. So this is the setup at the surface. Temperature anomalies, and this is July. So this gives you the broader setup. So July through September through the reanalysis. These are 2-meter temperatures. So just think, and this is in Kelvin, which is the same basically as Celsius. So the anomalies in here, essentially we had above normal temperatures over much of the southern Great Lakes down into the northern tier of the mid-Mississippi Valley back into the central plains, and much cooler temperature anomalies, at least historically what we know, out in the eastern United States or the Northeast, and then up into northern Canada. And also, it looks like over the western United States. So that is the temperature setup as the broad setup leading up to the event. As far as relative humidities preceding the fire, and again, these are only for, and this is for 1871, so the Peshtigo fire event. So they had records at Chicago and Madison in the early afternoon. And you can see these are the the departure from expected monthly relative humidities. So September and October, you had 9 percentage points lower in 18 in October, and then 16 and 22 at Madison. So that's the expected departure from normal relative humidities. And then the relative humidity 10 days before the fire. So in 1871 at those two locations, again, Chicago and Madison, notice, I mean, they were pretty low, you know, through late September into October, and then right before the main event on October 8th in Peshtigo in northeast Wisconsin, you had some pretty significant, these are some very low RHs, at least for the Great Lakes region. So, you know, it's kind of unusual, you know, from a meteorological perspective, usually when you have southwesterly flow out of the Central Plains and mid-Mississippi Valley, you wouldn't expect relative humidities quite this low because you're pulling up higher dew points or greater low-level moisture, so that it's a little bit unusual. And I think that has to do with that mid-level atmospheric setup with that upper-level ridge of high pressure. So you had quite a bit of drying, probably drier conditions over that whole region. So the dew points or humidity levels were probably not as great leading up to the fire event. So that may have led to, so you had dry bulb or air temperatures in the low to mid 70s. And as you increase the temperature, you know, your relative humidities go down depending on the dew point. So the greater the air bulb temperature, if you don't change the humidity level or the water vapor in the air, these relative humidities drop. So that's, you know, these are still fairly low though for, you know, Chicago must have had some rain on the 29th of September, or just higher moisture, or maybe a fog event down there. But these are all pretty low all the way through the whole first part of October. And notice the 13 in Madison, October 3rd. That, I mean, that's very low for the Great Lakes, especially in early October. I mean, I guess what I'm getting at is normally for these low humidities, maybe not in the early fall, but typically you have more of a westerly or northwesterly flow, like from the northern plains or out of Canada, pulling down that lower dew point or drier air. But these are the relative humidity setup preceding the Peshtigo fire. As far so these are weather conditions, and also there's some fuel conditions, and I think Robert Zeal at the next presentation will get into this a little bit more. But Sturgeon Bay, again, our location across the bay from Peshtigo, you had 63 degrees, 12 miles per hour. And then in Barris, there's that 75 degrees that was on that handwritten log in one of the first slides I showed you guys. And notice, at least the winds there at this time were not super strong, but Milwaukee, there's the 32, Chicago, 22 miles per hour. The one thing I wanted to point out as far as the fire danger indices, and these to me, you know, I'm not quite sure how these are off the Nelson system, but the Canadian system, the modern Canadian system uses a buildup index, which is kind of like what's the dryness of the fuels, and more of a longer term fire danger index that we use now. And I noticed in Madison that buildup index was 101. And just on a modern scale, I'm not positive, you know, if what this is relative as far as a percentile, but in the current day, like once you get up close to 100, that's pretty extreme as far as the buildup indice. And again, I'm not totally certain, like if this, you know, the national fire danger rating system, meaning like the US system, if this equates to the current Canadian system, but just to give you an idea, you know, and in Milwaukee it was 90, Chicago, the buildup index was 80. And this fine fuel spread index, again, this is similar to the modern, they have a fine fuel index as well in the modern Canadian system, and these are all very elevated as well. So just as far as the fire potential or fire danger, most of these indices indicate, at least from my interpretation, that they're pretty exceptional. And I'm sure they built these out of some of the historical weather records. So those are some of the observations and fire danger indices leading up to the Peshtigo fire event. So as far as so those are all the antecedent conditions. Then of course the weather setup that created the extreme fire event in Peshtigo. And what I want to do is kind of equate or show you guys, some of the modern technology that we use now, and and kind of equate to what I suspect was occurring back in 1871. So these, we've had, and I'll show you guys the fire activity year to date over the Great Lakes here in a minute, but these are the setups, and we've had my area of responsibility, like John said, includes Minnesota, all the way to Maine, north of the Ohio down to Missouri. So our problematic area this summer has been the upper Mississippi Valley, specifically northern Minnesota, at least through into mid-August. So we've had a lot of activity. These are the calculated soil moisture anomalies at the end of July. And I suspect if you went back to 1871, these, the soil moisture anomalies would be well down into these, the negative 100s over the central. Based off the mid-level atmospheric height anomalies that they've the reanalysis, I'm guessing with the drying and solar and above normal solar radiation, this whole area would be colored similar to how Minnesota is, like more of the central Great Lakes, possibly over into Minnesota. So basically the whole upper Mississippi Valley. And the drought monitor, which I showed you this graphic on one of the first slides. And this is the first time since this drought monitor has been done, I think back into the early 1990s, that parts of the Great Lakes, or at least Minnesota, has been categorized with D4 exceptional drought up in northwest Minnesota. Some of this has been alleviated in the past couple of weeks, but this has never occurred in Minnesota. And I'm guessing back in 1871 that we had some pretty at least severe drought conditions in place over the central Great Lakes. So I'm trying to, if I could repaint this to give a historical perspective based off of those precipitation deficits that occurred in the late summer of 1871 into the early fall, that you would have at least severe drought in place preceding the Peshtigo fire event. And I did read in one of the publications on the Peshtigo fire that the snowfall, at least from historical records, what they had, the snowfall in the 1870 to 71 winter was below normal for that year. So this is what occurred at the end of March 31st of this year. So we had well below normal snowfall over much of the UP down into northern Wisconsin into parts of Minnesota. So, again, if you recreated this, it would have been interesting to see what the snow depth departure from normals would be back in 1871. And then again, these are the percent of normal, the 30-day percent of normal precipitation amounts leading up at the end of July of this year. So all the fire activity has occurred, a lot of it has occurred over the northern half of Minnesota. Not quite as, Wisconsin, central Wisconsin has gotten quite a bit more precipitation over the past, I would say, 6 weeks or so. And it doesn't like to rain up here. And again, kind of referring to fire danger indices. If you had to recreate, these are energy release components. So this is the US National Fire Danger Rating System. This is one of the indices that the fire community uses to compute for fire potential, fire danger, like the Smoky Bear, when they put out the sign like that says high, a lot of times they're looking at things like this energy release component is how much, if you lit a fire, how much heat would come off the fire, and that's based on fuel loading as well as the dryness of the fuels. So back when those, like the Greenwood incident in northeastern Minnesota occurred, I believe it started in mid-August, like August 15th. These energy release components were at setting record levels above the 97th percentile. So if you went back to 1871, I suspect indices like these, the energy release component or that Canadian buildup index that I've referred to earlier that was up near 100, I suspect that they were likely above the 97th percentile. That's a little bit of guesswork, I guess, but based on those precipitation deficits, the above normal temperatures, like the 70, temps in the mid 70s, I suspect these were well above like the 90th percentile, which we set as like the very high for things like fire danger levels. So that's, I thought I'd just give you like some more modern graphics, and if you could just imagine shifting some of these things over more into, say, the central Great Lakes, I suspect that's what these would look like, based off of all the things that we talked about previously, the precipitation deficits, above normal temperatures, and those low relative humidities through late September into October from those historical weather records. And just to finish up here, I don't know why I chopped off 2021, but this is all in the Great Lakes region. These are the recorded years to date through August 31st. So and underneath that, this is the drought monitor drought levels, and it's a little hard to see with all this fire location icons on here, but it's not, it's pretty easy to pick out, where we had this long-term drying. That's where a lot of the fires have occurred through the summer, which is unusual. And normally, east of the Mississippi, we typically have a bimodal fire season. You have the spring before green up, and then also a fall season. Well, this year we've had a very active fire season in the upper Mississippi Valley. And, based on those, not to beat a dead horse, but based on the precipitation deficits of the relative humidity levels in that July through September mid-level atmospheric pattern, I suspect, that there's quite a bit of fire activity over at least the central Great Lakes through that summer into the early fall of 1871. I did read that March into April, they actually had quite a bit of rainfall in that spring. So it's a little different than this year. So it might not have been quite as active back then, but that's just, I guess, my perspective based on, our current situation and trying to line that up with what occurred in 1871. So more of what they call, and I mentioned this earlier, more of what a flash drought type situation likely occurred. And then you had what I read as below normal snow depths through the winter of 1870 to 71, which one thing that doesn't always mean you're going to have a busier than normal spring fire season, but the below normal snowfall or snow depths allow the finer fuels to be more vertical, like your fine fuels aren't packed down as much leading into the spring season. So that's another effect of below normal snowfall. So here here are the references that I use. A lot of these graphics were from the Donald Haynes and the Rodney Sando paper, and also the Great Midwest Fires of 1871. This is a paper that was done by the Science and Operations Officer here in the Twin Cities by Tom Holdquist. And I was given these references and papers by Professor Ed Hopkins. He's down at the University of Wisconsin in Madison, and that's actually my alma mater. He was actually a grad student when I was down there in school. So I remember Ed and I thanked him quite a bit for his help with this presentation. He actually worked with Tom on this paper, which I think appeared in a Midwest drought, the Drought Center, and down in Illinois. They published this in 2015. So that's where a lot of these historical graphics that I showed you, the black and white, came out of this paper from Donald Haynes and Rodney Sando. Don Haynes is actually, some of you may recognize the Haynes Index. He developed the instability index, a fire weather index, to give people an idea, scale of what the instability is for each day, like over a fire. If you have a high Haynes index or greater instability, that's when you have the potential for a vertical motion and a blow up on some of these larger fires. Just a side note. And finally, to end up, this is my contact information. So here's my email address and I'll answer some questions in the chat, but this is my email. If you have any further questions, feel free to email me as well, or you can give me a call.
Thank you very much, Steve. Excellent presentation. We do have a few questions, and I'll just start with the first one. The question is, I always think of fire season in northern Wisconsin being in April or May, springtime. How unusual is it to have these fire conditions in the fall?
I would say, looking at this historical, at least representation of what they think this, again, these are based off of some very broad, weather station records. Like, it's easier now to do these analysis maps with all the tons of data that we have. This pattern right here, it is unusual, but this would be very unusual, I would say, later in October and in November. But if you think about it, we get systems like this both in the springtime, where they get tons of snow in Colorado, and then we've got a bunch of severe weather in the Mississippi Valley, just based on this setup. So I would say, yes, it is unusual. Like, is 83 degrees in Milwaukee, above normal? Yes, but this can occur. I mean, early October it's still possible. So it wasn't like unprecedented, let's put it that way.
Okay, good. Donna asked if you could explain reanalysis. The question came up while the relative humidity levels preceding the fire was the slide.
Yeah, I think what I know, I had a trouble, I didn't come across what they meant by that as well. So that is a good question. I think what they did is they scour these old handwritten weather records and took what they could from these various locations. And I think what they mean is they tried to, because back then, like now, they release weather balloons like in, Green Bay, Minneapolis, International Falls, to get these upper level heights and temperatures and so forth. So I think what they might have done is taken the surface records and just kind of use that and try to recreate what may have occurred aloft. So like this reanalysis, they're taking as much data as they could gather from 1871 and some of those other large fire years in the late 1800s and just project upwards, you know, what the pressure may be aloft and so forth. So that's my, you know, that's my take on how they came up with these, like, these anomalies. I wonder that myself, like, how do they figure out what the mid-level flow was, you know, from this time period and so forth. But I think that's what they did. They basically, like, took all these surface records and just tried to, from what they know now, plug those into like computer models and try to recreate what the upper level and even the surface pattern is like this.
Okay.
I don't know. That's about the best I can answer that. So I apologize.
Okay, no, that's good. It brings up the next question from Tom, though, about what kind of weather instruments did they have in 1871? And then what about the accuracy of those weather equipment?
Oh, you mean like the instruments?
Yes.
Yeah, I think they basically, and I should pull up Don, that Haynes. I don't know if he gets into it, but that, you know, that's funny. I can try and find out from Professor Hopkins because he had a major role in like the instrumentation. There's another professor in Wisconsin that did that types of thing. But I bet they just had your standard, you know, barometer, you know, the tall that measured with the mercury in it, and then of course thermometers and so forth, and then hygrometers as far as measuring the relative humidity. So more, obviously more uh, vintage or whatever you want to call it instrumentation, but you know, they had things to measure the humidity, the pressure, and the temperature. And then I think what they do is they take whatever the old equipment that they had and feed those into it. And then like Robert Zeal, he talked about using like temperature and RH, and he said he could come up with Canadian drought codes, which are like a long-term fire danger index to compute those things. So back then they just had the basic instrumentation, and then, you know, they use that to I guess do that sort of like reanalysis that we're talking about.
Okay. The next question is, it looks like Wisconsin escaped this year's drought. Any explanation as to why the maps almost recognize the state line?
That's, I know, look at this. That's the greatest. I mean, normally I'm not the, you know, my colleagues out west are normally, you guys know, they're busy all summer. And usually things like, you know, especially east of the Mississippi, it's quiet in the summer because we're usually greener than Ireland. But it is unusual, like that's the $1,000 question. Like it just did not like to rain, especially in northern Minnesota. I mean, we've gotten more recently down in here, and then you guys over in Wisconsin, northern Michigan. Uh, I don't know. It's just the weather pattern. It's like the systems would form out in like South Dakota and then roll eastward, and then things just did not like to rain across the northern third of Minnesota this year. It's fairly. I mean, it isn't unusual in the summer, as you guys know, that we don't get as much stratiform or large scale rainfall events, you know, like the big, huge globs of rain that come across and give us in the, you know, it's usually like typically mainly hot and humid. Once in a while we get those Canadian cold fronts to come down to give us some relief. But in northern Minnesota, they didn't even get any up here in the spring. That was the problem. Like we just did not see your typical spring rainfall up here. Whereas in Wisconsin, I actually think like early in the summer it was on the dry side, even down in Wisconsin, but I don't have an explanation for it. And actually recently now, you know, far northern Wisconsin and the UP of Michigan over the last 2 weeks, if you looked at this map, it's actually dried out somewhat up in here. So I don't have a scientific answer why it's like on the state line, but it's just, you know, it has to do with the jet stream. And also another thing that my colleagues like at the Minnesota Fire Center, BJ Gleesner and Travis Vertigan, who used to work for Wisconsin DNR before taking the position with Minnesota, you know, when you have strong drought in place, that also drought begets drought. Like you don't have as nearly as much evapotranspiration from the ground up into the lower atmosphere either. So it's really hard to break drought when exceptional drought sets up. So that could be part of the reason.
Okay. Next question has to do with the wind speed. How did they have a way of measuring it?
Yeah, I think that's the other instrumentation part I forgot. I believe that they had anemometers back then. You know, like it's just, you know, you guys have seen them on, you know, like even like at golf courses, the little cup anemometer. I do believe they had those back then. I'm not positive, but I think they had those. And then, you know, the other thing I didn't mention is these lines of constant pressure, the 29 inches, you know, in here 29.2, and that's like the reading. If you had a barometer, that's where the mercury level is at. But the closer these lines are together, so they may have I think these readings are actually read from anemometers, but the closer the lines of constant pressure are together, the stronger the wind speeds. So, you know, you've seen it like on the news when they show hurricanes with all the rings around it, like the tighter those lines are together, the stronger the wind speeds are. So I'm sure you had some measured wind speeds, but some of these in here may have been just uh, pulled from the differences in atmospheric pressure.
We have a couple more questions. First one is from Mark, and it says, would the buildup index be similar to the ERC of today, energy release component?
Yes, that is true, Mark. So that's the Canadian Buildup Index, or, you know, in our presentation, that's from the Nelson fire danger system. And I think they're talking about the US system, but in the modern, what I use when I display, like I run you know, graphs such as this right here. I run these so this is the one from the data from yesterday. I ran this morning, September 1st. So it's true, the Canadian Buildup Index is the equivalent of the US energy release component, and it's more of a longer term fire danger indice. So very good, Mark, you're correct.
All right. And then another question is, can the Forest History Association of Wisconsin get a copy of Tom's research?
Of that reference this one right here.
Yeah, I think so.
Yep, I do. I will provide these two documents that were given to me by Professor Hopkins at Wisconsin. They're both good references.
All right, and then the last comment comment that I see is, can you show your contact information again?
Yes. And you know, just to clarify, I basically augment, you know, the National Park Service pays my salary, but I work for all the federal agencies and 20 states. So all the state agencies across basically the northeastern US, and I basically augment what the National Weather Service folks do, you know, on a the federal folks, they do what I would call days 1 through 5 as far as fire weather type products. So on the Greenwood fire in the Arrowhead, there is a National Weather Service incident meteorologist there. So I work with he or she, whoever would be on, like, say, that incident, and just my duty is to go out a little further, like in the medium range for planning type purposes for like resource movement, and also incorporate more of the fuels type information. And I do have, I can show you guys here, or maybe, let's see. Yeah, so my website, if you just search EACC for the Eastern Area Coordination Center, you will find our website, and there's all sorts of intelligence information on wildfire and all hazard information on there. So all of my products are located under like weather outlooks and so forth.
One last question, and it has to do with the availability of the historical weather records. Where do those come from, or where are those housed?
Those, I think, I have to look that up. I believe like the Wisconsin Historical Society has some of those, and you guys actually may know a little bit more about that. But I believe that information is referenced in these two documents where the records come from. Like say that embarrassed Wisconsin handwritten weather log and so forth.
Okay, good. There was a couple questions that had to do with whether the presentation will be available. And the answer is yes, we do record them. And by tomorrow morning, it should be up on the Forest History Association YouTube channel. And there'll be a link placed on our website also. So within 24 hours, it's available for use or viewing. And with that, I think I'll turn this over to John.
Okay. Well, we certainly hope you've enjoyed this evening's presentation. Please be aware that tomorrow you'll receive an email inviting you to complete a survey on your webinar experience. Please take the time to complete and return. Your advice is critically important to us in our efforts to serve you. We believe that all of life really is connected over the miles and years. Your advice establishes that connection between us and is the basis for our growth and improvement over time. Finally, make a note that this presentation connects to the next one on fire behavior, and we'll deal with the firestorms that were a part of the story in Peshtigo and a little community across Green Bay called Williamsonville. Showed up on Steve's map, where the talk was of a fire tornado. We hope you'll join us for more of the story in 2 weeks, and potentially check out the conference plans shown at our website. Thank you so much for joining us.